Let's solve another interesting problem of equilibrium where multiple bodies are connected with different kinds of connectors. So, as the picture shows, there is a bracket again which is bolted here, and then there are two sorts of clamps which are riveted like this, and they are pulling with 1.6 kilonewton force and 2.4 kilonewton force. And what you are supposed to find out is the reaction that this bolt is providing on this bracket. Okay. The question could be anything, either the reaction like that, or this bracket, how much force it is acting on that. So, either could be the question. Anyways, now to solve that, you can think in two different ways. One is simply you can just because it is asking for the reaction and there is only one point where it is grounded. So, you can shift all the forces and moments to that location and you will get a force and a couple resultant at that location at point O, and its negative will be the reaction, right, because that is the resultant of all the forces and couple moments acting at that, and because the ground is providing just the exact opposite of that, it is in balance. So, that is one way to do that. Suppose you do in that way, so what you will get is say suppose, okay, let me draw the free body diagram. Say, so this is my bracket, say, and okay, these are my axis, x axis, this is y axis, and this is z axis. Okay, and now, and there is a force here at some distance, maybe here, F 1.6 kilonewton, and then here there is a force which is coming like that, 2.4 kilonewton. This is F1, this is F2. Okay. Now, to find out the resultant, because that is one way to think of the problem, that reaction is nothing but the total resultant or the negative of the total resultant at that point. Now, how do you do that? Solve it. So, you just have to, so summation, so if you move all the forces there, so the summation of F resultant is nothing but F1 plus F2 vector. So, it is not at all a problem, and then that one will come to be, see, now F1 comes out to be say 1.6, that is the magnitude which is given, times this is angle 50 degree. So, I'll write in that form first, say magnitude times this, which will be 1.6 times its cos of 50 degree I minus sine of 50 degree j. Okay. So, that is F1, and similarly F2 will be 2.4 times cos of 30 j minus sine of 30 degree. So, these are degrees. Okay. K. So, these are F1 and F2. So, just sum them up and F resultant is given. So, the reaction will be just, so I will just say that, so the reaction force will be negative of that F1 plus F2, that is it. And what about the reaction moment? Okay. Now, for that you have to, because you have moved it, so you just have to get the compensatory couple moments. So, that is it, isn't it? So then for that what you need to do is you have to calculate these r's, say r1, and similarly for this simply this could be r2. Okay. Now let me write that. Say r1 is equal to how much? Say 0.2 I minus 0.35 K, right? Because yeah, so 0.35 in K direction and 0.2 in I direction. And similarly R2 will be how much? It's simple, 0.15 K. So minus 0.15 K. Okay. So then that's it. So R cross F is the only thing which you need to do. So negative of R1 crossed with F1 plus R2 crossed with F2. So that is what you will get, and yep, I think the answers will be so these are minus 1.02 028 I minus 0.853 J then plus 1.2 K. So this is the force, okay, and about the moment you will get so how much? 0.1172 I plus 0.36 J and 0.24 plus 5 K. Okay, so that is what you should get, and that is it for this problem. So this is a relatively easy problem, or else you could have actually another way is you can think that instead of doing this only this means shifting the forces and finding out the simplest resultant, what you can do is you can actually put the Rx means Ox, Oy and Oz means Ox, no, this is Oy, right? Oy, this is Ox and this is Oz. So like that you can put these things plus 3 moments, right? So My, similarly Mx and Mz. So 3 moments and 3 forces, you can write all of them and then balance the forces and moments about any point. For example, the point O itself you can write and solve for them. So that will be slightly lengthier, and then this is quite straightforward and short. Okay. So was there anything to be told? No, that's it. So see you then next segment with another problem.